Welcome to another episode of Code for Thought. What do rock climbing, forensics, and AI in medicine have in common? The answer is Janan Arslan, who I had the pleasure of meeting at the Brain Institute in Paris last year in 2023. And it was in fact Ghislain Veillant, who you might remember from a previous episode at the end of 2023, who recommended that I talk to Janan. And for good reason, because she has an absolutely fascinating career. Her career path is not exactly what I would call a straight line. It took her from her native Australia over the US to France, and from forensics to AI in medicine. And on top of that, she has won some awards, or was at least nominated for awards, like the one for explaining complex scientific matters in all of 3 minutes, the so-called 3-minute PhD challenge. Of course, I couldn't resist putting that to the test with Janan during the interview, as you will hear a little bit later on. Our recording was to take place in one of the meeting rooms in the Brain Institute in Paris, right in the center of one of Europe's biggest hospitals, the Hôpital Pitié-Salpêtrière in the 13th district of the French capital. As usual for face-to-face interviews, I brought all my equipment with me, which consists of a kind of electronic salad consisting of cables, microphones, a recording device, and a headset. Janan walked right straight into the preparation session, still recovering from an exhausting indoor climbing session the previous night, and there we were, trying to set it all up and getting ready for our chat.
Hi, how are you? It's funny talking into a microphone and not being able to, because usually when I'm talking into a microphone, I can hear myself. It's a bit funny now.
It is a bit funny now, isn't it? So you don't know what's being recorded.
No.
Hello.
Hi, how are you?
I'm fine, thank you. Question is, how are you?
Doing well. Pretty tired after rock climbing.
Well, that sounds exciting, and it sounds very much from Ghislain, I understand, that you had a very exciting career, which of course is what we want to talk about today.
Of course.
But we're getting far ahead of ourselves, so why don't you introduce yourself quickly, and then we go into the nitty-gritty bits.
Of course. So my name is Janan Arslan. I'm a postdoctoral researcher here at the Institute, or Paris Brain Institute, sorry. I'm located in the RSE lab, which is all about applying artificial intelligence, mathematics, statistics, and theoretical models to understanding medical diagnostics. I'm originally from Melbourne, Australia, and I graduated from the University of Melbourne. And my PhD was about applying artificial intelligence to ophthalmology, specifically an eye disease called geographic atrophy. Mm-hmm. So it was my job or my responsibility to automate the diagnostic processes, which was semi-automated before. And I did that, and also to understand the progression of the disease using mathematical modeling, and I did that as well. So it was very good PhD. And I'm having a lot of fun applying artificial intelligence to melanoma, which I know sounds bizarre because I'm based at the Paris Brain Institute, but I'm working in melanoma.
Because melanoma is a skin disease. Normally,
it is a skin disease.
Yes. Yeah.
And it's just myself and my intern and my supervisor, Daniel, who are the only people in this entire building that is, he's doing other things of brain-related as well, but we are the only people doing anything melanoma-related in this entire building.
Which has nothing to do with brain.
Nothing to do with brain.
But here you are.
Always the exception, never the rule.
Indeed. So what brought you to Paris in the first place? Because it sounds like you had a very good time. Well, you had a very good research time in Australia.
I was very lucky in Australia because as I was doing my PhD, I was also working as a consultant, a statistical consultant, and also a research fellow part-time while doing my PhD full-time. But Paris to me is a bit of an inspiration. It's kind of...
Is it?
Some of the greatest minds in history have gone through Paris. So I know it sounds very cliche of me, but it's the driving force behind my move to Paris, to be honest.
So stepping into the shoes of giants then...
I could only hope. It's my ultimate goal, but we'll see where my career takes me.
And your career is actually what we want to talk about. So let's talk about the PhD research you did in Melbourne and artificial intelligence and automating it all. And you need to tell us a little bit more about it, because I think you got an award for that as well, didn't you?
I was a grand finalist in something called the 3-minute thesis competition. So in Australia, I think the equivalent here in France is 180 seconds thesis competition. But basically...
Which sounds more, but is of course exactly the same.
It sounds much more grand in very Parisian style, in very French style. But its 3-minute thesis was originally from the University of Queensland, I think. The idea was conceived there. And it's all about digesting your PhD into 3 minutes in a very succinct but yet relatable manner so that the lay audience in front of you can understand your research very quickly. And I was fortunate enough to be one of the grand finalists. Didn't get the ultimate prize, but won the grand finalist. And yes, and I was lucky to get a couple of other kind of scholarships here and there. For example, I got the R.B. McComas Research Scholarship in ophthalmology for my PhD. So I've been fortunate to get a few scholarships and funds as part of my PhD journey.
Well, you know what's coming next now, Janan, because the 3-minute challenge means that you can explain it to lay people in 3 minutes. And here we are.
So my PhD was about applying artificial intelligence to an eye disease called geographic atrophy. So geographic atrophy is one of 2 end stages of the ultimate eye disease, age-related macular degeneration. Basically, anyone who has this eye condition, they're typically 50 years and older, so it's an age-associated disease. And also, once you have it, you are unfortunately stuck with it for life because we don't have any cures available. So when I talk about geographic atrophy, I'm referring to a branch of the late stage in which there's holes being formed within the eye. And the holes are formed there because as we age, our eye's ability to digest debris within the eye starts diminishing. So you start having this debris building up, and over time it builds up and builds up and builds up until the eye says, yep, I've had enough, I'm quitting, and you'll start having these layers within the eye start kind of degrading and collapsing and forming holes within the eye, which sounds frightening.
That does sound frightening, yeah.
And unfortunately, usually these holes are formed within the central vision or the macular region, which is responsible for central vision. So your ability to read, write, recognize faces is taken away from you.
Okay.
And initially, you will rely on your peripheral vision to help you get by. But then as the disease progresses, which it ultimately does, you will potentially can lead to blindness. So not everyone who has the disease becomes blind, but they certainly have irreversible vision loss. And my job was to automate the diagnostic processes they were using because it was very much human-based, very automated, very time-consuming. So I did that for them where they can automatically extract information about these holes within the retinal images. And then that was fed into a model which understands the progression of the disease. So how fast or how slow is this person going to progress? Because they are going to progress, but we don't know how or when. So my model helped in understanding that progression as well. So ultimately, hopefully, this information will help next stage of research, which is to find treatments to at least slow down the progression and hopefully eventually cure it entirely, if we can catch it early enough.
Well, you've done well enough, and in less than 3 minutes.
Oh, thank
so
you.
I'm very impressed. But that sounds very interesting. I think there are a lot of projects now at UCL in London, for instance, where we've been involved with a project which also uses artificial intelligence as a modeling tool, and we've built some kind of a data pipeline. So artificial intelligence is making its inroad into medicine.
Yes.
But I think as a supplementary measure rather than replacing.
Of course, absolutely.
Medical staff.
Because this is a pretty grave concern in the clinical world in general. In fact, I've heard the question asked a few times at different conferences. And realistically, artificial intelligence is a tool within the grand scheme of toolboxes. So the clinician is still the lead, the project manager, the person responsible for the treatment and the management protocols for the patient. But what artificial intelligence does, it makes those repetitive, time-consuming, arduous processes much easier for them. So they don't have to spend hours in front of a computer or analyzing data. It's just automated for them at the click of a button. And what this does, from my perspective, is it leaves the clinician open to provide more holistic approaches to their patient management. So rather than being so focused on the diagnostic processes, they now will have the luxury to build their rapport with the patient, maybe focus on other parts of patient management, such as counseling as well. So I think it actually improves and enhances patient-doctor relationship. But AI is just one toolbox in the grand scheme of things.
Indeed, and I think I heard it from somebody else, from a number of people, The reason I'm asking this question is exactly because it gets asked over and over
Exactly.
again. But another question that also comes up frequently is when you create models for artificial intelligence, I mean, you rely on a test data set and on a training data set, but for specific diseases, the training data sets or the test data set may be actually quite small.
Mm-hmm.
The question then arises, what kind of predictive value does that offer, and how can you get around the limited size?
Absolutely. So this is a daily concern for us as well, because medical data is, and it depends on the disease as well, but it can be scarcely available. So sometimes you might have a handful of images you're working with. So the issue we might be facing there is either overfitting your model or underfitting it, depending on the circumstances. So there are techniques you can use to get around it, but we can't shy away from the limitations. We have to acknowledge there are limitations, absolutely. But the way we try to get around it now is techniques such as cross-validation, for example. So if you have a sufficiently large data set, you can divide it into 5 equal parts, and then you can train with either 3 or 4 and then test with 1, and then you kind of just rotate these 5 boxes, we'll call them, over 5 iterations, so that what you're doing is you're exposing the model to different portions of the data as training and different portions as test, and then you're confirming that the model is able to, I guess, acclimatize to these different training conditions. So that's one method, and one that we typically go for because it's a very heuristic approach. We've seen that it works relatively well. But that being said, some of the limitations we face is if you, for example, in melanoma, we're working with particular tissue samples. The staining technique is very much prone to... So when I talk about staining techniques, we refer to coloring in these tissues to extract very specific biomarkers we might be interested in, such as blood vessels. But sometimes, because these processes are very prone to human error or staining artifacts, the tissue samples I have may not be identical to someone else's tissue samples, even though it might be the same staining technique. So your model may not always work outside of your own data set as well as you would like it to. But of course, there are other ways we can try to get around that. For example, you can make your model available. You can use federated learning, where rather than sharing data, you're sharing the model from institute to institute. And that way you're updating the model with different data sets. And in fact, probably federated learning is the best approach, because one of the biggest concerns and why we have limited medical data sets is because there's always ethical and privacy concerns about patient data. So federated learning is about several institutes kind of coming together, having kind of a shared repository, if you will, but that repository just focuses on updating the model with each institute's respective data. So you're not sharing your data, you're just updating the model based on whatever data you have. So it's a more robust model than if you were to work by yourself in your own little office. That's a couple of ways around it.
Oh, right. So that's quite a bit. So there's federated learning and then there's cross-checks. So which brings us to Paris, because you've now done a 3 minutes on your PhD in Australia. You can now do a 3 minutes of your work here in Paris.
Of course. So my work involves application of AI to melanoma. And the objective is to specifically understand how particular biomarkers, such as blood vessels, within melanoma tumors, help us understand better treatment response. I say this because the assumption is that as the cancer cells start spreading throughout your body, the areas that the host tissue it impacts, it starts converting it into this thing called a tumor microenvironment. So this tumor microenvironment becomes depleted of things that we humans rely on, so our ability to absorb oxygen and nutrients.
Right.
So the assumption is that because we have these tumor microenvironments being formed within our body, the chemotherapy that is given to us, it's not really taking effect because we don't have the pathways for it to take effect within our body. So unfortunately, in melanoma patients, the average survival rate is 8 months. At late stage. Early stage, it's still quite high because, well, comparatively high, because if you detect it early enough and you can have surgical interventions, it's easier, but late stage, the average is 8 months. But the problem is when pathologists look at these melanoma samples, and it's typically done using digital pathology, they might sound small, but the images are actually very large digitally, on average 90 to 120,000 pixels in height and width. So it requires them sitting in front of a computer, using a software and zooming in and out to observe these regions of interest, but it's also in a two-dimensional level as well. So my job coming in was to get these 2D sections, extract features in a two-dimensional level, do a 3D reconstruction on the melanoma samples so that we can see on a three-dimensional level how these different biomarkers are working. Hopefully use these features to then start understanding, okay, well, if the biomarker appears like this and the features are like this might start explaining why people aren't responding to their chemotherapy. So our current focus is blood vessel markers, so specifically looking at the size of blood vessels, how they branch, and this then relates to oxygen distribution, and then how oxygen distribution can impact chemotherapeutic response.
It also involves a lot of software, because when people talk about artificial intelligence, we all get very excited about model creation and analysis,
of course.
which of course is a very exciting bit. But it also comes with software. So how do you and your team get involved with that?
So far, all my projects have led to a interactive software being developed, because we are excited about the model, but what's the point of the model if no one can use it? So the objective is definitely to make it available to the end user, because for me, at the end of the day, it's a service to the clinician, to the pathologist, so that they have something to make their lives, if nothing, a little bit easier. So, of course, we've got the research component, but we do have the clinical component. So I have developed a few user interfaces in my time for use by clinicians. And I have to say, the whole process is fun, but that last bit is like big tick. It's like, yes, we're here, we're now doing this. So no, I have developed user interfaces as well and software for clinicians to use. For user interface, I rely on Python's PyQt5, so I heavily rely on that. But there are different ways to do it, but that's my go-to. And in fact, I think my colleague who sits next to me also uses that.
It's a Qt client for Python, isn't it? Qt is sort of like a special C++.
Absolutely. So I found that to be very useful. You can create much more interactive user interfaces, and there's even a way for you to design it before you start implementing the code as well. So I personally like it.
Because Python probably is also a relatively low threshold between the machine learning aspect, which probably is what you do in Python as well, I'm guessing.
All my machine learning, deep learning, everything is in Python, but I've dabbled in C++. For all my AI-related work, definitely Python.
May I ask what kind of technology stack you're using? So there's Terraform, there's PyTorch, etc. This
is a bit of a controversial response. So
is it?
In our group, you're either a PyTorch person or TensorFlow Keras person, and I happen to be more TensorFlow Keras. So I'm kind of in that camp, but I transitioning to PyTorch. In fact, most of our lab uses PyTorch for their development. But between those, I've typically been in the TensorFlow Keras camp for quite a while. We have whole discussions about this, including Python versus MATLAB. That's a whole different other discussion.
So I'm interested in it because there is a software engineering, which of course is very big in research, and no research can happen without software engineering. But then people often treat machine learning and artificial intelligence as if it's something separate. You have the data scientists, and then you have the software engineers. Is that something that you would agree with, that distinction, or do you think they kind of blend into each other?
I mean, we can certainly make distinctions, for example, distinctions between machine learning and statistical learning, one of them being uncertainty analysis, where you try to account for human error. But that being said, there are overlaps. I'd say they're kind of blended in together a little bit.
Which leads me to the next question, which is, of course, getting hold of people who can do the work, because we now have people who are trained in Python, but people working with machine learning. I did a course on Coursera once, never used it in earnest. But so how difficult is it actually to get people for this kind of work? And are we missing something in terms of training, do you think?
That's a very good question, because I haven't quite reached the stage where I do a lot of recruiting. It's going to be a bit of a naive response, but there are quite a few qualified people out there as far as I can see. I don't know if it's necessarily the training, because I was approached by a master's student who wanted to check in with me, should I take a more computational path or mathematical path? My recommendation to him, and again, this is because I do AI math stats, the whole works. My recommendation to him was actually take the math part, because then you can learn the coding later. For me, the math and stats is important, because you want to look at things from a fundamental level, from a first principles level. Then you apply the coding to that. So that is more important. But in terms of qualifications, no, there are quite a few highly qualified individuals. It might be just a matter of interest to how they want to apply their skills. So maybe they're not too academically geared. Maybe industry is more preferable. There are certain kind of trade-offs between the two, where industry might offer a bit more comfort, whereas with academia, you for me, it's about following an ideal for hoping to achieve this particular goal in my life, which is to hopefully make a significant change or significant contribution in some way. But in terms of qualification, it might be just in addition to qualification, people just might need to have more hands-on experience as well.
Let's go back to your career again,
Sure.
because I think there are a few more things that we haven't talked about yet, apart from the rock climbing, apart from the 3-minute challenge, because I think there was some forensic element somewhere, wasn't there?
This is where the multidisciplinary side comes in. My bachelor's was in forensic science, which itself is multidisciplinary because it's about not only biology, it does involve also computer science, also mathematics, and law. So you have to understand all these things to be a forensic scientist. But the thing is, in Australia at the time, it was very challenging to try to find work as a forensic scientist. But in order to graduate, you have to do some sort of placement or internship. So I ended up finding an internship at a genetic company. After my internship, they wanted to hire me, so I stayed on. And then after there, I thought, okay, I want to broaden my horizons. Let me go over to the US. I might learn more things. So I ended up transitioning to the US. And so the genetic area I was working in is called pharmacogenetics.
What is that?
It's all about understanding drug response based on your genetic heritability. So if you've ever had something as simple as paracetamol, for example, and you've noticed you've got side effects, that can be explained by your genetics. So I went to the US. I initially was an associate, but when I arrived there, things were a bit of a mess, unfortunately.
In what way?
Well, no one was really around to train me, so they kind of let me be. And I thought, okay, so I just went to IT. I was like, look, I'm new. They haven't actually trained me how to use any of this. Do you mind if you give me a test user access so that I can go crazy, test this environment without impacting the front end? So if you're a test user, you can do whatever you want and nothing will happen to the front end of the application. And they did that. And I very quickly realized, oh, God, this is very manual. It can be improved. So I ended up improving it, automating the whole thing. And because I did that, they promoted me very quickly to director.
Oh, wow.
It was like,
okay. Was that still forensics then that you're working?
Yeah, that was pharmacogenetics as well.
Okay.
And then through that job, I realized, because then that led me to doing also things like prediction models and also more automation. And I just realized I had an affinity for this kind of work. So I went back to Australia. I did a couple of masters in statistics and bioinformatics. And then once that was finished, I directly went into my PhD.
Okay, so you didn't stay in forensics very long then.
No, in fact, unfortunately, there weren't any positions available in forensics. It's funny, though, how my career deviated because of lack of opportunities in that field, but I'm actually very happy it worked out. So for anyone who's listening, if it doesn't work out at the time, you never know where life takes you. So just go off the flow. Trust it.
Yeah, indeed. I think that's a good recommendation, actually. So whereabouts in the US was that? So
Houston, Texas.
Oh, Houston, Texas. Okay. This is basically where you kind of developed your computation and your front-end skills, etc. Also the administrative skills, I guess.
Absolutely.
As a director.
Absolutely. It was a great experience. Very quick learning curve, as you said, the administrative skills, because it was kind of the first time I had that much authority given to me. So I wanted to make the most of it. I have to say it was quite fun, to be honest.
And now you're here in Paris. I don't think we talked about when you arrived here in Paris and when you started your role here.
October 2021.
Oh, right. That was in the middle of the pandemic then.
Very much in the middle. Australia, or Melbourne specifically, was still in lockdown when I left. There were only myself and 6 other people at the airport when I left that day. I've never had a better flight in my entire life. The whole plane was just, if you booked first class that day, you wasted your money because the whole flight was just for us.
Right. So what's in store for you in the future? Bearing in mind that career paths always meander and go different directions, but where do you see it going in the future?
Well, interestingly, I was very fortunate to have been offered a position at the Institute. So my postdoctoral contract is ending very soon, but I was fortunate enough to be offered a senior engineering position here at the Institute in the data analysis core team. And in addition to everything I've been doing, I've also been teaching at Sorbonne University in 3D modeling, C++ programming. So I've been asked to keep teaching in those classes as well. So life is good. I'm very, very happy.
Are they permanent positions that you're being offered?
The senior engineer position here is a permanent position, yes.
Oh, right. Because I understand that in France, the senior positions are probably not that easy to come by, the permanent positions.
No, I've been told, which is always a bit frightening when you're told permanent positions are not easy to to come by. So I was very happy when I got one. It's like, yes, I can breathe. It's like I can relax a little bit.
That sounds all very exciting, and I wish you all the best for the future and for the research and for the rock climbing.
I'm definitely going to need it for the rock climbing for sure. But thank you so much for inviting me as well. This has been an absolute pleasure. Thank you.
Yeah, my pleasure is all mine. Oh, time's up. See you next time. But before I forget, this podcast is covered by the Creative Commons license. See ya.